Okay, we're going to do some examples together, just a few more using the same formulas that we reviewed yesterday. Not learning anything new, just sort of reinforcing what we have been working on. So I have a two-way table, and I have information about how much students sleep, and the information is categorized by less than 6 hours or more than 6 hours. And then I have information as to how they performed on an exam, whether they passed or they failed. And I have my joint cell counts, which basically show that 12, for example, both passed and got less than 6 hours of sleep. Then I also have my marginal cell counts, which basically are either the column totals or the row totals. And then the final thing is I have my table total showing me how many students we were observing for this. So the first question says, to the nearest percent, what is the probability that a student who failed the exam got less than 6 hours of sleep? So most students can sort of figure out this is definitely a given condition, but it's hard to figure out which one is the given condition. So start by thinking which one has to be looked at first. So what's the probability that a student who did fail got less than 6 hours of sleep? So our given condition is the student failed. But we really want the probability that they got less than 6 hours of sleep, given that this has happened. So it's going to be the probability of less than 6 hours, given that they failed. So I'm going to use my formula, which says look at the intersection of the two. So I need less than 6 hours with failed. It's these 10. And then I'm going to put as the denominator the given, which is the failed. So I'm looking at 10 out of 18. And I'm just going to really set these up for you because that's what we really need practice doing, just to save time. So that's the first one. The next one says, to the nearest percent, what is the probability that a student who got less than 6 hours of sleep failed the exam? So essentially, you can almost ignore this part because you're really looking for the probability that the student failed the exam. So what is the probability that a student who got less than 6 hours of sleep failed the exam? So this is my given condition. You may think that it always comes first. It doesn't always come first, but very often the given condition does come first. Solve the probability that someone failed given they got less than 6 hours of sleep. And again, I start by looking at the intersection. Those that failed and got less than 6 hours of sleep is 10. And then the total that got less than 6 hours of sleep is 22. So you can see how these two are different outcomes. The last part for number one is, what is the probability that a student got less than 6 hours of sleep and failed the exam? So this is your key word that you're looking for, the joint cell count here out of the table total. So it's going to be these 10 that failed and got less than 6 hours of sleep. So it's 10 out of 120. So let me write this out for you. This is really just the probability of less than 6 hours and failing the exam. And in this case, I don't really need a formula. I'm just looking at the total in the joint cell, which is 10, out of the total in the table, 120. So that's how you would approach that without using the formula. All right, the next one is talking about botanists, and they're testing new fertilizer, and they have certain percentage of the plants that are producing flowers, that kind of thing. They want us to do a table. So we could do a tree diagram, but let's do a table since they suggested that we do that. Plus, we did the tree diagrams yesterday, so you should feel pretty confident about that. So when I construct the two-way table, I need to start with my two pieces of information. So first, I need to know whether they got the fertilizer or not, the new fertilizer, and then I need to know whether they produce flowers. So I'm going to say flowers, and I'm going to say yes or no. So I'm just kind of starting my table. I'm going to erase this since you already have that. And then I need to know if they got fertilizer, and that would also be yes or no. So crisscrossing this, I have yes, and then I have no, And then I'll have my different marginal counts and my table total. Which, if we're doing proportions, we're just going to leave this at 1 here. Now, I could convert this all to numbers. I'm going to start by establishing my proportions first. So, I need to know the total that received fertilizer, and 70% received the new fertilizer. So, of the total plants, 0.7 did receive the fertilizer. So I need to go to where my fertilizer is yes and come down and do 0.7. Okay? Now, of these 0.7, it says that 40% produce flowers. So I need to find the number that goes right here. So I could almost use my formula, which I know that if I multiply 0.4 times 0.7, it should give me this amount. So I'm simply doing 0.4 times 0.7 in my calculator, and I get a 0.28. So kind of think through that. If 40% of this total of 70%, so it's just 0.4 times 0.7, 28% of the overall plant, so about 28 orchids received the fertilizer and produced flowers. Then to fill this in, I simply subtract from 0.7. So 0.7 minus 0.28 is 0.42. Then it goes on to say, of the plants that did not get the fertilizer, 10% produced flowers within a month. So again, I'm going to take those that didn't get the fertilizer, which is 0.3, and multiply by this 0.1. And that's going to give me 0.03. Okay, and I need these to add to 0.30, so this is going to be 0.27. Now, if you need to, by all means, do a tree diagram. I can kind of show you this pretty quickly. So here I have fertilizer, I have no fertilizer, and this is a 0.7 to 0.3 ratio. Then from the fertilizer, those with plants is 0.40. And then if I multiply along here, no, I'm sorry, it wouldn't be 0.40. Yes, it would, sorry, 0.40. So now when I want the probability that the plant receive fertilizer and produce flowers, I'm just kind of abbreviating there, it'd be the 0.7 times the 0.40, which is 0.28. So that's what we learned yesterday. So you could set it up either way. So I need to make sure everything adds up. So 0.28 plus 0.03, and that's going to give me 0.31 here, and 0.42 plus 0.27, I'm just simply adding up, making sure everything matches, and this is 0.69, and yes, so now I know everything is good. So now I can answer some questions. So find the probability that a plant that produced flowers got the fertilizer. So this is going to be the probability that a plant that produced flowers got the fertilizer. So I need to determine my given condition. So given that they got the fertilizer, I want to know the probability that the plant produced flowers. So they received the fertilizer, and I want to know I need to know the probability they got the fertilizer given they produced flowers. So that's the way I'm going to look at it. So the probability that they got the fertilizer given that they produced plants. So I'm going to focus in on just those that produce plants. It's 0.31. And of those, 0.28. So it's going to be 0.28 over 0.31. So the next one says find the probability that a plant that got the fertilizer produced flowers. So I know the probability that they produce flowers given they got the fertilizer. So this is going to be the probability to produce given they receive the fertilizer. So I'm going to look at just those that got the fertilizer, which is 0.7. That will be my denominator. And then I'll know the probability that they produce, which is going to be 0.28. So in both cases, you can see the numerator is the intersection of producing flowers and getting fertilizer. So it's then the denominator that you have to focus in on. And that should help get you started. Just a recap of what we've been working on. So now you'll work on the homework, and I have left that with a sub for you. So hope you have a great day, and I look forward to seeing you guys again tomorrow. Bye.